just want to thank Alistair very much, who was instrumental in inviting me to this conference. And I want to share a story that occurred at lunchtime, and I hope the person will not mind me sharing this story. He turned out to be a fellow academic from Oxford. We'd never met before, but it turned out we had a mutual colleague. And he obviously was a little bit confused that I was here, and he said, I was talking to this mutual colleague last week, and I said, I'm going to this conference, and Sarah Harper's going to be giving a talk. And she said, are you sure it's Sarah Harper? She's a demographer. And I think that really sets up something which isn't only obvious maybe from your awareness of population, but also in the first talk we heard the Planet Under Pressure conference. And I knew the organisers very well, and they were very, very keen to get demographers at that conference. And 2 sessions were submitted on demography. And I think one of the issues has been, as someone who comes very much from demography and population, who has entered the environmental world, this is not my world, but I've entered it over the last 3-4 years, I suppose, is that there is this real mismatch between the way that demographers and to a certain extent economists look at the world and the way that environmental scientists look at the world. And how I became involved, I suppose, is that in a minute I'll take you through some of the changes we're going to see, but one of the things that my institute works on is actually the major population change of the 21st century, which isn't growth, which you'll see in a minute, it's actually the change in the age composition of the population. And in my world, this is the story. The whole world is going to get older. There are certain opportunities for certain parts of the world, basically Asia, Latin America, and Africa coming up within about 20-30 years' time. They have something called a demographic dividend, and this is the chance when they'll have lots of young people in their population able to drive their economies and societies. And it is all about growth and consumption in order to keep these societies and economies vibrant for the next 20-30 years before they start getting into population aging. So coming from that world, I then started to meet the environmental science world, who were saying quite the opposite. No, we've got to reduce material consumption. And I think one of the things at Oxford in the Institute we started thinking about was the 2 really big challenges for the 21st century is tremendous changes in our population and tremendous changes in our environment. But they, in many ways, are conflicting, and resources are being put into basically driving these 2 different changes, and yet they're very much at conflict with each other. So we wanted to think about ways that we could bring these 2 worlds together and start tackling the population issue and the environmental change issue within one kind of a framework. So this is really what my talk is going to be about. I'm sure you're all aware that we have just recently hit 7 billion people. On the day, there was a lot of interest. It was United Nations Day. Does anyone know what day it was? There you are. October the 31st, last year, was United Nations World Population Day, because that's the day we hit 7 billion. The other side of the story is that I was doing a BBC interview that day, and the interviewer said, how do we know that today the world has hit 7 billion? How do we know the 7th billion baby was born today? And that just really demonstrates another big issue. Not only, obviously, this world wasn't quite aware that it was a 7 billion day last year, but also there's a lot of myths around population and what is happening to it. So my aim is just to take you through the population challenge of the 21st century and hopefully try and link it into some of the concerns that we've had. And I hope you'll see a lot of synergies between what I'm going to talk about and the first talk we had this afternoon. So this is going to be the outline. I just want to take you through the demographic transition. I think it's really important that we understand the demographic transition. Take you through this idea of population-environment interactions and show you our conceptual schema, which I hope will fit into the way that this audience is looking at things. And then I'm just going to give you 2 very simple case examples. There are many, many examples, but one is around the change in our age composition and the way that that will interlink with our environment. And the second is a piece of work that we're doing on the fertility transition in Africa and its relationship to food. Now, when I was a student of demography about 25 years ago, the really, really huge question was how can we stop the world population hitting 24 billion? That's what we believed. we thought we were going to have a maximum world population of 24 billion by the end of this century. Then it came down to about 12 billion, and now actually we think we probably will hit about 9.8, 10 billion by 2050, and then we'll probably flatten. And the reason is something that 25 years ago we simply didn't see, and that's falling fertility. Because across the globe, women are choosing and having the ability to control their fertility, and they are reducing the number of children that they are having. And we shouldn't be surprised about this, because it's all part of a story that started about 200 or so years ago, and that's called the demographic transition. And very, very simply, I'll take you through the demographic transition. One can say that most societies 200, 300 years ago were here in stage 1 with very high fertility and mortality rates. That's high birth and high death rates. And the example we can think of is the UK, or England, should we say, in about 1780, and current day Nigeria, which has about 7 births per woman of reproductive age. Then what happens in the demographic transition is that as you get economic development, and we're not quite sure exactly what the dynamics are, the death rate starts to fall, particularly infant mortality. And in response to infant mortality falling and the death rate falling, you get a dramatic increase in your population. And this is what we saw in England in the 18th and 19th centuries, and it's what we're seeing at the moment in a country like Ethiopia. And then, probably in response to the death rate falling, the birth rate starts to fall. So in other words, women realise that if they want to raise 6 children, they don't have to have 12 babies. If they have 12 babies, they'll have to raise 12 children. It's more complex than that, and I'll tell you about it in a minute. But basically, the birth rate starts to come down. This is what happened in England in the 20th century, end of the 19th, 20th century, current day Uruguay. And then you have where most developed world countries now are low fertility and low mortality. And so again, Canada, most of Europe at the moment, US, etc. So the demographic transition is leading to some very big changes in our population. And in a way, we've seen this coming. This isn't a surprise, although we didn't realise how quickly we were going to have the birth rates coming down, particularly in the south. And so obviously one thing it starts to do is reduces the size of the population, and that's why we've gone from maximum world population of 24 down to about 10. It changes the age composition of the population because mortality rates go down. First of all, infant mortality, then mortality across the life course starts to fall, and now we have late life mortality falling. And I'll talk about that a little bit as well. And because you're having less children, the age composition of your population goes up. And as we'll see, this isn't a European issue, this is the whole world is aging, and it's aging quickly. It also changes the distribution of your population because people start to move in response to these different types of population dynamics. One of the reasons why we've had a large number of migrants into the northern hemisphere from the south is because we were aging, we were wealthy and we were aging, and we exported economic capital to Asia, Africa and Latin America in return for human capital, migrant workers. That probably is going to change quite dramatically over the next 20, 30 years. We'll not be able to prop up our aging economies with workers from the south because those populations are also aging. And then the final big change is changes in density. Now, one of my colleagues from the LSE, Tim Dyson, he believes everything can be explained by the demographic transition. He even believes urbanization comes out of the demographic transition. I'm nearly there. I'm not completely there. I think there are other things going on. But his argument is that in a rural area, as you come here, you get this dramatic natural increase. The rural area cannot support. Therefore, people move into the urban area, and that is a result of demographic transition. So that's a simple way to explain what is happening to the world's population. How do we put this into the bigger picture? This is the demographic diversity that we are likely to see across the 21st century. So we're starting here at 2010 and we're going up to 2100. The world is in grey. As you can see, we probably will hit around about 10.5 1 billion. When you're so far out, you can't exactly say, there's obviously huge variance at this level, but most people think it will, as you can see, sort of flatten out in the second half. Here we have the more developed countries, and we're going to stay at roughly 1.3 billion. We're going to have an increase in the less developed or the emerging economies, particularly in Asia. They will end up at roughly 6 billion of the total. And you can see down here the least developed countries will hit round about just under 3 billion. So this is how, as a sort of demographer, we put this into some kind of conceptual schema. So up here we have our population, and it is not just about population growth, it is population size, distribution, density, and composition. And here we have the environmental impact, and yes, there clearly is some kind of a direct impact between these variables, and things like climate change, environmental footprint, resource use, natural capacity, and the actual human impact. But clearly, as we heard in the first talk this afternoon, the biggest interaction is here, patterns of consumption. And this, if you like, is what really is the segue between our population change and our environmental impact. So to put it quite simply, it's the kind of argument that we may only have 1.3 billion worth of the population living in the north at the moment, and we may have 6 billion in emerging countries. But it is unthinkable that we can continue to have the kind of consumption differential that we have at the moment. And therefore, as demographers, one of the things we're interested in is obviously how we shift those patterns of consumption away from, for example, Africa, where we have societies where people don't get enough calories, so their immune systems are compromised and they become sick, and raise those calories and at the same time tackle a question which we find in the US and actually also here in Europe of obesity, where we very much overconsume calories, we become obese, and our immune systems are compromised and ill health follows. So that's the sort of general schema. And just to give you a very quick example of some of the kind of projects that we work on. We're just looking at a project at the moment where we're looking at changing in the African total fertility rate. Africa's total fertility rate is quite high, as I'll show you in a minute. And one of the things that we're particularly interested in is what is it that's keeping this total fertility rate high. And we have a group that are beginning to look at things like the interaction between the natural environment and sustainable development. To put it very simply, the story is that if households begin to understand that by having large families, they're degrading their local environment, they're unable to sustain those families on the kind of land that they have, maybe they will take the decision to have less families because less children, because those children won't migrate out, they will stay within the family unit. We have another project where we're working with the Department of Zoology in Vietnam, and this is the beginning of a project around food production. And we're looking at small holdings and the contribution that small holdings make in terms of food to the overall food pattern of the globe. And we're looking at what happens when these smallholders age. And the reason they're aging is because young people are leaving the land and going to urban areas. And if this is happening at a time of environmental change, when there is huge demands to take on, for example, new technology in order to cope with the kind of environmental stresses that they're coming upon, and yet they are old, they are female, they're illiterate, what are the kind of interventions that can be made to adjust to that? And then we have another project where we're looking at, it goes back to what I said at the beginning, the sort of demography world and the environment world. We're looking at the city. Some of the things that we've been talking about when we look at inclusive urban developments, age-friendly developments, are actually very similar to what the sustainability, the eco-city group are talking about. So we're beginning to sort of combine that kind of work. But let me just take you through two very specific projects to show how population and environment maybe can be brought together. This is going to be looking at changing age composition and environmental impact. This is the total fertility rate mapped currently across the globe. Now, total fertility rate is basically the number of children, of women of childbearing age. And you can see, if you look at the yellow, that's below replacement. And you can see that in actual fact it isn't just up here, but down here, that we are having countries that are coming down below replacement. And if you take the brown into account, these are countries that are heading for replacement. The vast majority of the countries in the world, 2/3, are now at or below replacement. Thailand and Vietnam have lower total fertility rates than many countries in Europe, for example. Urban India is now below the UK in its number of children. And in fact, it's only sub-Saharan Africa, which I'll come back to in my second example, where we still have these high, over 4 children per reproductive woman. But let's run this across the century and see what's going to happen to our population. What we've done here is we have actually mapped the number, the percentage of children per country going forward. And you can see that in 1980, large numbers of the world had well over 1/4 of their population children. And in fact, this includes countries like Afghanistan and Pakistan, where you have nearly 50% of the population children. Many parts of Africa are as high as that. But if we run this forward, you can see that the yellow, the blue, which is in between, and the yellow start to disappear. That's by 2000, by 2010, by 2030, by 2050, and by the end of the century, you can see that there are just some isolated pockets where they still have roughly over 20% of their population children. So the children of the world are basically, as a percentage, beginning to disappear. And the reason why economists are so worried about this is because what does that then do to the working population? So we can, again, very simply and schematically map this. This is the population aged 15 to 64. Again, this is in 2000, where you can see we had here, this is over 2/3, and the yellow is 70% of your population is of working age. By 2010, we had obviously large parts of the world that had well over 2/3 of their population of working age. But again, 2030, if you look, the yellow and the blue start to disappear, and we start to drop down to below 60%, so that we have a real dramatic shift in the working age population of the world. Now, of course, to a certain extent, there's a massive caveat, because it's highly unlikely in 2100 that we will still define mid-60s as a time when you stop working. But you, in fact, probably actually in about the next 5 years. But you can see how this dramatic change in our population composition is going forward. And this is just very quickly, just to show you the percentage aged over 60 by 2050. And if you look at the green, the blue and the red, that's over 1/3, over 25% and over 20% of the population who would be currently defined as older. It is, with the exception of sub-Saharan Africa, going to affect most parts of the world. I just wanted to show you this, just because I think this is just really for interest. We recently mapped the number of centenarians in the UK. There are currently 12,000 centenarians in the UK. By 2050, there will be 500,000 centenarians, and by the end of the century, there will be 1 million centenarians here in the UK. 8 million people in the UK will make it to 100, and if we extrapolate this to Europe, 127 Europeans will make it to 100. These are Europeans who are currently alive. So we really are shifting our population, which obviously has huge implications for things like health, the transfer of resources across the generations, etc. This is why it's seen as a major issue in the 21st century. I just want to very quickly take you through some of the implications, some of the science that has been done looking at this age structural work. Introducing age composition into the environmental change debate, really, I think there have been 3 main areas. To clarify the potential range of predicted environmental consequences of energy-related emissions. One of the really interesting areas that we've been working on is with a group who work in building physics in Cambridge, who are into air conditioning, and in talking to us, we realised that, of course, if we're going to have an ageing populations cannot control their temperatures as well as younger populations, yet all the predictions on the amount of air conditioning that will be needed in a, for example, heat sink city that increasingly will be getting warmer are based on younger people and not on older people. So they've started to recalibrate their calculations going forward, taking into account the ageing of the population. And again, to allow better estimates of the cost of reducing emissions and to understand the energy demand across different demographic groups, and particularly looking at things like the relationship between cohort and age. And just to give you an example, this is probably Brian O'Neill and Liddell are probably the two people who are doing most of this work, but this was some very early work they did, and they just showed, if you looked at the age of the householder, then the capita energy consumption changed because one's lifestyle changed. In other words, here, this is the age of the householder along here, and you can see that energy consumption from transport goes down, but from residential goes up. This was very unsophisticated 10 years ago, but since then we've had, I think, some much more sophisticated work that has built age structure into these calculations going forward, and I've just listed a few of probably the top things here, including this last paper, which is very interesting, which is looking at the difference between age and cohort, because obviously we carry forward also generational behaviour. The behaviour that most people in this room have is different from the behaviour of older people, and one of the reasons that the early work was criticised was that they carried forward current ways of behaviour of older people into the future and didn't look at generational differences. And then, just as a second example, this is the work we're doing on fertility transition, food and Africa. I just want to take you back to this. If you remember, we were talking about maximum world population. Now, the maximum world population is based on the idea that Africa is going to come down to replacement by the end of the century. They currently have, there are over 4 children per reproductive woman. The UN median prediction is that they will come down to 3 by 2050, and that they will then come down to a replacement by the end of the century. If, however, the current childbearing rates continue in Africa, we will not have 3 billion Africans by the end of the century, we will have 15 billion Africans, and we will be back to a world of 24 billion. Now that's highly unlikely, but I think there is a real feeling now, and not just from obviously academic demographers, but from African governments, African communities, and from African women themselves, that they want to be able to control their own childbearing and have the same decisions that other women in the world have over how many children that they should have. And the work that we have been doing is around the impact of education, because there seem to be 3 big macro dynamics as to why women bring down their fertility. One, as I said, is around infant mortality. One is around family planning, and without doubt the spread of family programs is important. But the third one, and we think crucially, is the education of women. And what we've done here is just map the percentage of women of reproductive age with at least junior secondary education. And if you look, these are where we have 80%, and down here we have less in many cases than 40%. And that, obviously, there is an association there between the total fertility rates, which are low here, and they're high here. But actually there's some very serious work that's been done on this. If you look at, for example, in Ethiopia, women without secondary education are having 5 children on average. Women with secondary education are having 2. In Nigeria, the difference is between nearly 8 and 5. And there's some very interesting studies coming out, again, from Africa, which shows that regardless of your education, you have knowledge of contraception, but you are very likely to use contraception if you have secondary education, and not so likely to use it if you don't have secondary education. So we really believe education is the key here. And I just want to finish by just giving you the example of a project we're doing with the World Resource Institute, and it's around food. And this is just a quote from the report about Africa being one of the hungriest continents, home to 44% of the world's hungry people, etc. And one of the modellings that we did was look at the food consumption, and we looked at predicted calories plus different population scenarios. And this is food consumption comparing the developed countries to 2030 and sub-Saharan Africa. And this is keeping it constant at 2011 levels, which is, one would hope, highly unlikely given the lack of nutrition in these red countries. And this is modelling which says that if we could bring down the developed country down to developing country levels and Africa to developing country levels, but if Africa was to go to the developed country level, we would have a considerable increase in the need for calories. And what we did was, when we combined the predicted increases in population growth with the predicted increases in the much needed calorific intake in these countries, we saw a rise in total global demand for food of 40% by 2030 and 70% by 2050. So then what we did was we did some modelling around the total fertility rate to see how much we could reduce the population and therefore obviously reduce Africa's commitment to having to produce food for its population. And again, if the replacement, if sub-Saharan Africa is at replacement by 2050, it would reach 1.6 billion, which would be 360 million fewer people. And if we could maintain that between 2050 and 2100, that would bring it down to about 1.8 billion rather than 3.4 billion. And then the World Resources Institute did some calculations about how much that would reduce the predicted calories, and it said a reduction in sub-Saharan African population by this 360 million would reduce global food demand by approximately 401 trillion calories per year, 7% of the predicted global calorie gap in 2050, and reduce the growth in sub-Saharan Africa's food demand by roughly 1/3 by 2050. And this is just very early work, but we're trying to bring these two types of modelling together. And the final thing we did was to say, right, if we believe it is education, how much would it cost to provide secondary education to everybody in Africa between, you can see the figures up there. So, again, this is a very rush through trying to introduce you to what we do and how we link it together in different projects. But again, we as demographers believe it's environment and consumption that is the key. And also that I don't think we should be frightened about talking about the population problem. People often say, why are you talking about the population problem? It isn't a problem. It is a challenge. It's not just about growth and size. It is a complex, different array of how people are going to be living in different parts of the world, consuming differently, with different pressures on different resources in different parts of the world. But the key thing to take home is that fertility rate is going down in almost every country outside sub-Saharan Africa, and that there is a growing demand within Africa itself that the women would like to be able to control their own fertility, and we believe that education is the key to that. Thank you.